So like I said, today we're going to talk about asynchronous code in JavaScript. We've talked about it before, but we're going to do a bit of a review. We're going to talk about working with promises. So the stuff that Axios gives back when we're trying to make an API call. Promises are a concept outside of just API calls. So it's not just something unique to Axios, it's something that JavaScript has as a whole. And then we're going to actually use Axios to grab data from our Hacker News API and integrate it with our application so far. So I'm not going to start off with the React News site yet. I'm just going to create a JavaScript file outside. So we can demonstrate some asynchronous code. Okay, so let's look at some code that's doing things. So let's say, before I do that, okay, so let's say I have a function that is supposed to wait for a certain amount of time. So I'm gonna call it wait. It's going to take in how much time in milliseconds we want. And here we're just gonna grab our start time equals new date. So this is how you can get the current time, not data transfer, new date dot get time. So this is a built-in JavaScript function that allows us to get the current time that we're working with. I want to console log it so you guys can also see what it looks like. Start time. But so for waiting, we're just gonna do a simple while loop, and we're gonna say while we're gonna create a new date dot get time. So while the time right now is less than our start time plus our time, the wait time, pretty much. I'm gonna call this wait time. Wait time in milliseconds. So basically this loop is going to run all the way until we've reached our wait time. That's what this code is doing. And the while loop doesn't need to do anything. We're just kind of wasting time. Okay, so let's do console log here. Okay, so we're gonna console log hi. We're gonna then wait for 5 seconds. We're gonna console log hello. And then we're gonna wait 6 seconds. And we're going to console log. Yet another hello world example. Okay, how much time do you guys think that this would take to execute? So we're going to run this. We're waiting for 5 seconds, printing out a log, waiting for 6 seconds, and then doing another log. Yes, correct. It's 11 seconds. So let's test it out. To run a JS file, I'm just going to do node main.js. And there we go. So hi, this is what the time looks like. So I'll explain why it looks like that in a sec. So it printed out hello, it's waiting, now it printed out world. So it took roughly 11 seconds, or it took probably exactly 11 seconds, maybe a little extra for compute time. So why did this code take 11 seconds?
That sounds like a really rhetorical question because you literally told it to wait 5 seconds and then wait 6 seconds.
Yes, it's happening synchronously. So it's going to go one line at a time. It's going to wait and then do something, wait and do something. So our date looks like this. We will see this you'll see this quite often. So this is, I believe, called like Unix date. It's the date in, so if it's in JavaScript, it's the date in milliseconds from January 1st, 1997 or 1970. So computers, that's how they keep track of dates. Their clocks started at that time, and it's been running ever since. So this is the running time since then. So a few minutes ago when I ran this was the start time. And then this was the next start time. So see here, it was 5 seconds difference, which is exactly what we did. So we had to wait for 5 seconds, and then we ran the second one, and it was 5 seconds afterwards. Okay, so this is synchronous code. A lot of times we don't want to wait for things to happen sequentially, so we want to do asynchronous code. So let's use this neat function called set timeout. So set timeout allows us to give it a function and how much time to wait. So time in milliseconds, let's say I want to wait 5 seconds. So this function, after this 5 seconds, these 5 seconds are up, I want to print out hello. Oops. So this is going to be a callback. So I just need to fix the syntax. But okay, so timeout takes in a function that is going to run after our timeout time has expired. I'm gonna comment this out. And let's see what happens. What do you guys expect to happen?
Same as before.
Same as before. So we're gonna wait 5 seconds and then wait 6 seconds. So it's gonna be 11, right?
Yes.
Okay, let's see. So hi, 1, 2, 3, 4, 5. Okay, so it waited, but then we see world and hello printed out at the same time, or world was printed out first and then hello was printed out. Why do we think that? We can actually,
It did 5, then 6, well, 6 and 6 there, or yeah, 6 and 5,
Mhm.
then world, versus the other way. It was, we waited 5, then hello, then 6, then world. So it's like 11 between them.
so this happens asynchronously. So set timeout will start the timer pretty much when it executes this line. It's not going to wait until it returns. It's going to immediately start counting. And so it starts counting, and then it starts counting for the second one. The second one finishes first, so the world is printed out, and then the timeout finishes afterwards because we're waiting for 6 seconds, and then it prints out hello. The lag, it printed out the same, like world first and then hello earlier, because probably just the timing of the execution of the lines. But basically, when you're using something like this, you are, it's executing, it's starting its timer once it gets to this line, once it gets defined, and then it moves on to the next line. And when the timer is done, regardless of where everything else is in the code, it will print out this line.
So could you actually, you could set a variable with the time, and you could do some math on it after every process and show how many seconds it was, instead of having to look through those numbers and do the subtraction. Couldn't you just have that create a time hack after every operation?
To create the time, yeah. I mean, depends on what you're trying to do, but you can. So this is just demonstrating that things that happen asynchronously will get run, and then it will move on to the next one, and then it waited for 5 seconds. So It started a 6-second countdown, it waited, and then it finished before this one finished. So that's why we got world and then hello. Yes, Lewis.
I got a question. So how was it asynchronously? Like, how did it know when to like start when the wait function started, you know? Don't you have to put like async before wait
No.
set timeout?
So we're not wait. So wait here is not the keyword await that we've been using. So await, this is different. We'll talk about that in a bit. That's when we're working with promises. But right now, so set timeout is a asynchronous function. We could probably. Does it return? What does it return? Oops. Set timeout. Return. Okay, so it returns an integer of the ID. So that's not, so we're not going to use this with async await. This is just a built-in function that is asynchronous. So basically when it starts running, it will start counting the time, and then when it finishes, it'll run this function that we defined.
Then I have a question. Why are they saying that is asynchronous if the line 16 and 19 are going at the same time? Is not that supposed to be synchronous?
So this happens asynchronously. So whatever's inside is going to happen, like it's asynchronous because it starts a process separate from the process that is running here. So when I'm running this file, it's going line by line, right? So it goes to 10, prints out hello, or sorry, prints out hi. It gets to 16, it calls set timeout, and then it starts a timer. And we don't wait until this timer is over to run this function. We immediately move on to this, but in the background, the timer is still ticking. So we start off the timer here, and then it goes to line 19, and it calls a different function. This one is called wait. So I can do another set timeout for a different time. So I'll just comment these out. So this one, let's say, is going to take a shorter amount of time, and this one is going to say world. So when I run this, it's going to wait to. It's going to print out world and then wait a second and then print out hello. So when it gets to this line and then it gets to this line, it executes the set timeout function, which is it's executing this it's starting the function asynchronously. Sorry, it is executing the function synchronously, but it won't actually print out or do whatever you want it to do internally. It's just going to start a timer, and then when that timer runs out, then it will run the code. So because of this, when I triggered line 16 and I triggered line 18 finished first because I have a shorter amount of time, and then line 16 got executed. So the hello console log got executed. Did that clear enough?
Yes, thank you.
Awesome.
I got another question, Zena. I'm so sorry.
Okay, no worries. Yeah.
I'm just still trying to process this asynchronously stuff. And so, okay, so you say when it goes to line 16, it just starts a timer, right?
Mhm.
So the time is ticking once it reaches to 18. So it won't be exactly 6 seconds. It will be like 5 seconds. So, or something. I mean, that's how I'm assuming. And then when it gets to 18, then it starts at 5 seconds as well. So shouldn't it, by the time like it reaches 18, the 6 seconds should be like around like 5 seconds, and it should print out around the same time? Or does it
so
like,
in theory, yes, but it's not gonna take an entire second to go from
Hey, I
executing.
found this on
lines.
the web for a Siri yes. Check it out.
Siri, excuse me. Okay. So, okay. First thing, these are different timers. So the time that is starting here does not affect the timer that is starting here. So that's one point. I don't know if that was anything that you touched upon, but I just wanted to clear that up. Secondly, in theory, yes. So if we started this timer and then between these two timers, we did 1 second worth of code execution. So we had like a bunch of lines of code, and all of those lines of code ended up being a second. And then we started the second timer, we would probably have them executing at around the same time. So if it took more than a second to get to the second timer, then yes, this would have caught up by then because it already started counting. So then it could probably print out hello before world. But that's only if there's enough time in between the two.
I get it. Okay, I think I was just thinking that, I mean, I didn't know that the program is that fast when it reads
Oh, yeah.
through it,
Yeah, they're fast.
but thank you.
Of course.
Hey, Zainab.
Yeah.
So I have a question. So when you had the first set timer up with the console log of hello,
Mhm.
and you also had the wait function up, that was executing world and hello, right?
Mhm.
But that was because the timer is set to 6,000 and the wait function was 5.
Yeah, because this one's fast. This one ended up executing faster than this one.
So if I set it to, so if I set wait to 10, that should print the reverse, right?
Yeah, if I set this to 10, it's definitely gonna print this one out first. So if I run this, we'll wait. After 5 seconds, it should print out the first one, should print out hello. What?
Yeah, that's why I was really confused. It did that to me and I was like, okay,
Oh,
I
think
don't
it's
understand.
because- I think because this loop is taking up, it's actually like taking up the time. So it's not. So even though this is happening asynchronously, I think we have to wait for this to finish looping to actually get any of the printouts.
Okay.
But that doesn't make a lot of sense. Hold on. We're gonna try this one. So I'm gonna make this one 10. Okay. Yeah, I think because it's not actually happening asynchronously with this wait. This wait is happening synchronously, it's happening while the program is running. It's taking up the program time pretty much because it's stuck in this while loop until it meets that condition. Which is why we ended up with that weird behavior, even though we were waiting. But asynchronously, if let's say this one was taking 7 seconds and this one was taking 5, this would print out 2 seconds before the first one, which is what we would expect. Awesome. Yeah. Any other questions?
Yeah, I'm curious how do you tell it to execute code outside of the function without exiting the function? Because I guess that's what was happening with the wait function, because it's not asynchronous. It has to complete what it's doing before it will execute the code. So what is that function doing to tell the program to execute code outside of that function?
This code or this code?
Yeah, on 14 and 17.
14 and 17. So this set timeout function is what is handling that. So it automatically runs asynchronous code. So it's just a feature of asynchronous functions. It is built in pretty much.
Okay, thank you.
So yeah, so set timeout is one of the asynchronous function. Another asynchronous function is set interval. I think this is going to be pretty helpful for you guys too. So it has a similar structure. It's going to take a callback function as well. And then the second parameter is going to be the interval time. So let's say 3 seconds. So whatever code you put in this callback function will get executed every 3 seconds. This is basically what it's doing. It's setting up an interval that you can run continuously. So this might help maybe in when you're getting API calls and maybe you want to refresh every 10 seconds or something like that. So set timeout and set interval both return the ID of this new like interval or timeout instance. So interval ID. So if I just said console log, so in this interval, I just want to print out in interval every 3 seconds. And then let's see. Oh, I should probably comment this stuff out. So it hit an interval first, and then, yeah, so all of this is happening asynchronously. These 2 timers started running, and then the interval started running. And so whichever started first, which was the interval, because it was 3 seconds, that got printed out. Then world got printed out because it was 5 seconds. And then in interval again, because it was supposed to hit like the 6 second mark. And then hello printed because that was at 7 seconds. And then it just keeps going on and on and on. So we don't like infinite loops. What am I doing? Okay. So typically, you want to clear your intervals once you don't want them anymore. So once you, maybe your components die, actually, I think if the interval lives within the component and the component unmounts, it automatically clears it. But if you want to clear your interval, you have to do clear interval and then send in the interval ID. So I can, if I do this, nothing is going to actually happen. We won't see an interval at all printed out because it's going to create an interval and then delete it immediately. I could put it in a timeout function if we want. And set timeout. So we're going to clear this interval once we, once we hit like 4 seconds. So it'll run once. I'm gonna comment these 2 out. So yeah, we're setting an interval. This will run every 3 seconds, but then when this timeout hits 4 seconds, it's gonna clear the interval and our interval is gonna stop. So let's see. So an interval and then it stopped. Any questions on this? Am I missing anything in the chat? Okay. Awesome. Okay, so this is just talking about intervals and timeout and just kind of seeing how asynchronous code works. So let's look at promises. Can anyone remind me what a promise is? Give me your best.
When you
guess.
make a request, When you make a request, the server will send you back a basic promise, which is an object that says, "Hey, you got the request."
Basically, yeah. So a promise is a built, so it's not only tied to server requests. So promises are a JavaScript construct that specifies that a future value is going to be returned. So it allows you to have a value now, but you have to wait until it resolves to actually use the value inside of it. So it's like an actual real world promise. Okay, I promise to do this, which means that you probably will get this thing, but you don't have it yet. So I'm going to comment this stuff. Actually, I'll just make a new file. Promises.js. Okay. So to create a promise, and this is what basically Axios does in the background when it's returning a promise for us when we make an API call. It creates a promise and then it returns it to us. So I'm going to create a promise myself just so we can see how they work. So I'm going to call it my promise, and the way to create one is new promise. Yes. And what this promise takes in is a function. Okay, so there are two variables. There are two parameters, sorry, in our function here. We have two functions inside of it. I know it's a little bit of nesting, but a resolve function and a reject. So actually you can see it here. So there's a resolve one and then there's a reject one. So this resolve and reject function will allow us to define what this promise will end up resolving to or resulting in. So when we make an API call, so let's say I make an API call here and I got my data, I would want to resolve this promise. If I'm making an API call and I don't get any data or I get an error, I want to reject it. But we're not going to be like, Axios already returns a promise, so we don't want to nest them too much. But we can say, let's say we have a function. Do something. And this function just returns, let's say a random number. Well, this function checks if this one random number is greater than 0.25, let's say. So random gives you a value from 0 to 0.99, so before 1. Or does it hit 1? I'm not sure, but basically percentages. And this is just checking that it's going to give us a value above 0.25. So this will be true or false. So let's say here, let success equals do something. So success is going to be either true or false. So we can say if success, oops. Keep mixing up Python and JavaScript. Okay. So if success, then we can say resolve, and we will send in whatever data we want. So we can say, we can just send in a message or a value or whatever. So typically when we call Axios and it returns data to us, it puts the data that it wants us to get inside of this resolve function. So whatever I return here, that is what I will have access to in my response when I'm doing the like promise dot, then, using syntax syntax. Okay, so we're going to resolve this to it worked, or it was a success. And then else, we want to reject. And then this reject will say there was an error. Okay. And these functions can be named anything. This is just an alias for it. But basically, the first one has to resolve the promise. The second one will reject it. That's the only thing. Like the order matters, but the names, you can name them anything. Okay, so we created a promise. How do we now consume it? So my promise, so we usually get promises back, and then we do a dot then once they get resolved or rejected. So inside of this dot then, I'm going to grab my data. And then I'm going to console log this data. So this one will be on success. And then data. Okay. Let's see what happens here. Oops, I ran the wrong code. Hold on. Node promises. Okay, so it was a success. Let me run it again. Okay, so the first time we got a random number that was above 25%. So this was true. It ended up resolving the promise to a success. And then when this promise was resolved, or the data that was returned was success. So success, it was a success. This was the information that I sent in this resolve function. So on the second run, it ran into an error. So it says here, trigger uncaught exception, and handle promise rejection. So basically, the promise was rejected, but we aren't handling it here. That's what it's trying to say. What can we add here to handle an error or a rejection?
Try catch or try accept.
Yeah, so try catch, we can use that, but there's a built-in one. So if we're chaining these, so if I'm chaining the dot then, I can add a dot catch here, and that will do the same thing. So the dot catch is going to catch an error. And then I can do whatever I want with this error. I can just console log it. So this one is rejected. And then I can just grab the error and print that out. So I'm gonna run it again. There was an error. Okay, cool. So if I keep running it, every now and then I'm gonna get an error or a success, but as long as it's handled, I'm not gonna get any like ugly errors. Okay. Any questions about this?
Yeah, I'm so sorry, Zena. I had to step out real
No.
quick. Can you explain? I forgot what a promise is again.
So a promise is a construct built into JavaScript, and it pretty much gives you a variable to hold on to, but it won't actually return or it won't evaluate to a certain value until it has been resolved or rejected within that same promise. So like typically we do our Axios calls. So if I said axios.get, and here's my URL of some sorts, this returns a promise. So we usually end up doing the dot then, right? So dot then is going to capture whatever that promise resolves to. So we usually take in response, right? We can name it anything. Here I named it data. here I'm gonna name it response. And then, okay, listed these wrong. And then you can like print the response. Response. Okay. So basically, this is the same as using this, but here I'm making my own promise versus having Axios return me one. That is the difference. And the promise, so when the promise is defined, so when it gets to line 5, it defines the promise. And then it does something, it does all this stuff. And we hold on to the promise object, which is this variable. And then when we want to grab what it resolves to, we can say the dot then. But just to be clear, when our promise is created, it gets executed. So this is basically asynchronous code. Once it gets created, it runs. And then when we're grabbing the data, that just gives us the information. It's not going to get run when we say dot then. It gets run when we're actually defining it.
And where did we define that data? Is that just
Data, this is
variable, right?
this is us grabbing whatever is inside of our resolve or reject. So think of these as two different return functions, kind of like these are returns, but here I'm returning this data as a resolution. So I'm saying that this, whatever happened in this promise was a success, and I would like to return data to you. If you're rejecting, then you're gonna say that something happened, there's an error. I'm gonna return this error to you that happened. So if there was more complex information stuff here and we had like a try catch, if there's a catch, then we want to reject. If it goes into the errors, then we want to reject. But if whatever code we wanted to do was successful in what it wanted to do, then we can just resolve it like this.
I got a question, Zainab.
Uh-huh.
So for axios.get, do you need the dot then? Like it will still run even if you don't put the dot then, right?
Yes, it will run, but you won't be able to access the value that comes from it. So you can say let response equal to axios.get. But this won't actually, you won't be actually able to use this response because you didn't really wait for the promise to evaluate. So that's why we would need the dot then, because it will only happen once it gets resolved. So let's say here in my promise, I had a timer. So just so we can simulate that it's taking a long time, and that's why we want to wait for it to respond. So let's say timeout. I'm not really going to do anything with this timer. But I'm gonna say that it will take 3 seconds. So I'm gonna comment this one out, I'm gonna comment these ones out because these won't work. So here, okay, it printed out, it was a success much faster. I think I need to, in the timeout, resolve it for it to work because this happens asynchronously. Okay, if success, then we want to set timeout to resolve after 3 seconds. So it took some time and then it resolved to success. So we did that because if we wanted to say, if I wanted to console log my promise, right? Because this is basically what this is doing, right? We're grabbing the promise that Axios returns, and then we're putting it inside of a variable. And let's say we want to print it out. So this, me doing this is basically the same thing. I could say response equals my promise, and then I'm printing out response, but this is the same. So I'm gonna try doing that. So it says that this is a promise and it's pending. So it doesn't have an actual value yet. That's why we have to put it out then. We want to wait for this promise to resolve. A lot of times, like when we're using Axios, these promises are getting data from external APIs. So it's going to take some time to get back to you, pretty much. So we have to use the .then to signal that we want to wait until this promise is not pending anymore. We want to wait until it has been resolved. So promises JavaScript. So these are the docs. There are promises are in one of three states. It's either pending, fulfilled, or rejected. So fulfilled is what it's resolved. I can actually, that's a better way to name it. Fulfilled. Okay. So it can either be pending, fulfilled, or rejected. So, oops. So before it actually gets to send me back the information, so this is where it's sending back the information. Before it does that, we have to wait for it. And one way of doing it is by using the .then. Another way of doing it is by using the async await keywords, right? We've seen these before. So we would have to put yeah, I'll show the async await version in a sec, in a cleaner example, but yes, we have to wait because the response in the beginning is going to be pending, regardless if we wait or not, actually. So let me see here. It might be immediate just because code is pretty fast. Yeah, so when I printed out my promise, it was a success. That's what it resolved to. It's actual data came back. But before, because I was waiting a little bit, it took some time and it was still in a pending state, which means if we were trying to grab the data from there, that data would be undefined. Did that clear it up? Cool.
Yeah, it helped me a lot. It's because like when I always use the Axios, I didn't know why we needed the then. It's because we just use it just to console log something, but I didn't really see a point to it. But I always done it because you did, but I just didn't understand. But yeah, it really did help. Thank you so much, Elena.
Awesome. Yeah, you're either using a .then or you're using a wait to wait for the promise to resolve, pretty much. Okay, let's do. Okay, so you can. There's another way of catching errors as well. So you can have. Actually, I won't show this. This is not that important. Maybe towards the end. Okay. Let's do this stuff and comment this out. Okay, I'm going to show one last example of promises, and then we'll get into working with Axios. So let's say we want to make breakfast. Okay, so we first want to wash dishes. Let me see. Okay, so this is going to be function. I cannot type this morning, but it is okay. Okay, so we're gonna wash dishes. We are gonna pour cereal. We're gonna pour some milk. Oops. And then we can eat. Okay. So for washing dishes, let's say this will return a promise. So we're starting off with washing dishes, but we haven't finished washing them yet. So we're going to return a promise that you will get your clean dishes. So new promise. And in this promise, we said we're going to take fulfill. Is that how we spell fulfill? One L in the beginning? Sure. And reject. So we're gonna fulfill this, and then we're gonna, let's say we're not gonna reject today because we're gonna wash our dishes because we want to have breakfast and we don't have a clean bowl. So let's do a timer. So let's set timeout. And this function is going to then fulfill. And we will say we washed a bowl and a spoon. How long do you guys think that should take? Two seconds, 3 seconds? Okay.
10 seconds.
10 seconds, let's do it. Okay, so that takes 10 seconds. Let me just copy this over. So then our next task is to pour cereal. So we pour some cereal. And maybe this takes like 3 seconds. Then we're gonna pour some milk. Milk. Say that takes us 4. And then we want to eat breakfast. Let's say eating breakfast, we're just gonna get to the end. And we're gonna just console log. Now okay. So we want to wash dishes, pour cereal, pour milk, and then eat breakfast afterwards. Seems pretty straightforward. So in the chaining way, in the way that we chain our dot thens, our resolving what is it called? Promises. So we would have to do wash dishes, and then so wash dishes is going to return a promise, and this promise is going to either be resolved or rejected. So we want to put a dot then. So this dot then, let's say it takes a result, right? And this result, then we want to do yes, so this result can then be taken and put into our next function, which is pour cereal. Because we want to call the pour cereal after we get a result, right? And let's say we want to send in this result in here. That means we have to take it in up here, results. So this result is going to be piped into our next function call, right? And this function is going to return another promise. So we can do another dot then and keep chaining them this way. It's probably better to put them on new lines just so it doesn't get too crowded. So I can do end results for milk. And that will also take the results. So once we wash dishes and the result returns, I want to print it out in the next stage, so I can print the result that I have. I have to do console log. Result. Okay, so this one, I'm gonna do it for this one as well. And then eat breakfast, we'll have the final results. Results and print it out. So we're gonna pour cereal, then pour milk, then eat breakfast. So you can actually do, you can do this way where you specify the name of the variable and then put it into whatever function you're calling. You could also just do this. You can specify that this result is going to go into here. So if I run this, so we're going to wait 10 seconds for us to wash a dish. Okay, we washed a bowl. So that one went through, took us 3 seconds to pour some cereal, 4 seconds to pour some milk, and then it was resolved. And we finally called our eat breakfast. We can also say finally. I think that should work as well. Okay. It is, I'm going to make this a little shorter so we don't have to wait this long the next time we run it. Okay. So the finally did not work because it did not take. So here we saw undefined printed out up here, and that is from this line. So when we used finally, this just calls a function. It's not actually going to take in the result of the previous nested one. So here I would have to do another dot then. Okay, so if we wanted to catch any errors, we can put a dot catch, we said, right? So we can have a function that says go hungry. So if none of this happened, if one of the steps didn't go through, we are going to go hungry. So this is going to be equal to, or it's going to take in an error because that is what we're defining this function to be. We're having it be an error handler for us, basically. And then we can console log our error. And then we can actually just say whatever we want. We can just say, I'm gonna go hungry now. Thanks a lot. Okay, so we could catch, when we catch an error, whatever's in here will execute. So this function in here will execute. So I'm just going to say we can go hungry if we catch an error. And let's simulate an error. So maybe our pour milk, instead of fulfill, it will reject. So if we run this, okay, wash the bowl or cereal. Okay, poured some milk, but then we got an error saying that we poured some milk. So when we rejected, I guess we should have said no milk in the fridge. That would have made more sense. It'll say no milk in the fridge. I'm gonna go hungry now. Thanks a lot. So this is how you can specify what happens on an error. Slightly funky. It's gross. Another way of doing this, if you don't want to put a dot catch, you can up here in all of them, you can specify two functions. So either, we already said that this result is going to be piped into this, right? So we can either take pour cereal or go hungry. So in every situation, you can either, The first one will be what happens when you get a resolved promise. And the second one is going to be what happens when you have an error. So if you want, you can just put all of these and you don't need this dot catch. And this will say, if you have a response, if you have a fulfillment, then call this function. If not, call this function. So if we do this, so the first one should go into pouring milk. So we printed out that, sorry, pouring cereal. So pour cereal, went to pour milk, but had to go hungry because there's no milk in the fridge. Any questions on these? No. Okay. So let me show the async await way of doing things. So this is one way where we call our first function that returns a promise, and then we keep chaining more and more functions that create promises pretty much. But another way of doing this is making one function. So I'm going to make a function called prep breakfast. And this function, oops. And in this function, we can do let results equal to. So first thing we want to do is wait washing the dishes. So when we're using the async await syntax, we have to put async in front of the function that we're creating. And then every time we want to call a certain function that will return a promise, we will have to say await. So await is going to say, let's wait until this promise is fully resolved, and then we can use the result that it returns, pretty much. So this is similar to the dot then. Dot then is basically saying, let me wait until this wash dishes promise returns, and then I will move on and execute whatever is here. So I'm going to await wash dishes, and then I can go on to the next one. So sorry, not return. So I'm gonna call the next one result equals await. What's our next point for cereal? And pour cereal is going to take in the result of my first one. So result, and then you keep doing that until you get to the end. So result, pour milk. Nope. Milk. And then at the end, yeah, we got to the end. This is right. Just pour milk and then eat breakfast. So after we're done, we grabbed all of our results. We can just say eat breakfast. And you can actually return this. Return eat breakfast with the results sent in. Okay. So how can we catch an error here? Let me run this. Let's see. It should give us the same stuff. It's going to get stuck on the error that we're rejecting over here. So we'll get an error or not. Oh, it's because, okay. We're commenting out this way of doing it, and then we're going to actually use our function here. So I'm going to call prep breakfast. And this function is going to go in, it's going to call our first function that returns a promise. It's going to await the results coming from that function, and then it's going to send it into the second one. So how can I add error handling here? Someone mentioned it earlier.
If statements.
If statements is one, try catch, yeah. I think try catch would be our best bet. So here we got the same error, trigger uncaught exception. So if you ever get this or unhandled promise rejection here, whenever you see this, just look to see if you have try catches around your promise handling. I'm going to try this. Okay, and then catch. And what should I return here if it's catch?
Some sort of error message.
Yeah, so I already have a function that handles my error handling. So it takes in an error and it prints out the error message. So I can use that. So I can return go hungry with an error. So my catch is also going to take an error. I forgot to do that. Okay, so catch, it'll catch my error, whatever it is, and then it'll send it into go hungry. Now, if I print it out, we should get an elegant error handling. No milk in the fridge. I'm gonna go hungry now. Okay, awesome. Any questions on this? I can go back to, I'll keep it. Questions about using like async await versus dot thens, or just how promises are working? No, everyone's a pro. Awesome. Okay, let's take a little break.